Humidifier, Dan McCarthy, back with you again. Today we're going to talk about commercial air conditioning. First thing we want to talk about is this is a roof array. These are just an aerial picture of some roofing air conditioner units, quite a few of them. The American Society of Heating and Ventilation Engineers, or the ASHRE, in 1929 defined comfort air conditioning as the process of treating air so as to control simultaneously its temperature, humidity, cleanliness, and distribution. The same definition applies today, but there have been certain refinements as the art has progressed. Comfort air conditioning or climate control means the maintenance of the atmospheric factors affecting comfort. Specifically, it is the maintenance of the following variables, all within well-defined limits, and by systems which do not contribute an objectionable noise. Number one is the desired temperature, of course. Number two is the acceptable humidity. Three is the minimal atmospheric particles, including bacterials and particulates. Number four is an acceptable odor level. And number five is the uniform air pattern and the air motion. We're going to talk about dry bulb, wet bulb, a few of these items that make up the air conditioning systems and the calculations therefore. Number one, let's talk about dry bulb temperature. This is the temperature of the air measured by an ordinary thermometer, is basically called the dry bulb temperature of air, commonly referred to as the DBT. When the ordinary thermometer is exposed to the atmosphere, it indicates the dry bulb temperature, which is nothing but the atmospheric temperature basically. So let's move on a little bit here. Here's another roofing array that we have. A bunch of condensers on a rooftop. These are commercial air condensers. This is another picture of some conditioned air, all the units, rooftop units. Here we are, wet bulb and dry bulb. Let's talk about wet bulb now. The wet bulb temperature is the air also measured by an ordinary thermometer, but the only difference is that the bulb of the thermometer is covered with a wet cloth. This is the wet bulb temperature, commonly referred to as the WBT. When the air comes in contact with the wet cloth, it absorbs some moisture and gives up some heat, so the temperature of the air reduces. The reduced temperature is measured by the thermometer and is called the wet bulb temperature. We've got a little diagram here that is indicating wet bulb temperature in Fahrenheit, and we've got dry bulb temperature in Fahrenheit also. The dew point. The dew point is the temperature of saturation at a certain atmospheric pressure. For a given atmospheric pressure, a dew point is the temperature at which moisture condenses into water, droplets, or dew. A reduction in temperature below the dew point will cause condensation of some of the water vapor. With the formation of condensate, there will be a release of some latent heat of the vapor, which will have to be absorbed and taken away before any more condensation can take place. So that's just a factor that you need to know about dew point, which we're going to get into here in just a second. The other factor that we're going to talk about real quick is relative humidity. The term relative humidity is more widely used in the field of HVAC and air conditioning. It is defined as the ratio of the mass of water vapor present in a unit volume of air at a certain temperature to the maximum mass of water vapor that can be accumulated in a unit of volume of air when it is saturated. I know that sounds pretty scientific and everything, but I'll explain it here in just a second. Relative humidity is expressed in percentage. It indicates the actual humidity percent in the air at the prevalent temperature conditions and widely used by air conditioning engineers. So relative humidity is a big factor. What we want to get into, here's the relative humidity, same situation as before, basically the same graph. We've got the relative humidity at the top here. Let's talk about psychometric. Psychometric is the science of air. There are psychometric properties of air. The psychometric chart is a graphical representation of these psychometric properties, such as we just talked about: dry bulb, wet bulb, dew point, and relative humidity. There are many charts available from various equipment manufacturers and other sources. You can come up with some other charts. The ASHRAE chart is the most commonly used for the calibration of engineering the air conditioning systems and equipment and schematics. Is the ASHRAE chart is used. And let's get a shot of this. That's it right here. So basically, the psychometric chart is the ASHRAE chart, and we've got our relative humidity in the purple. We've got our empathy saturation is in black, our wet bulb is in blue, and our dry bulb is in green. So this chart, our relative humidity is in red as well. So this chart basically covers all the bases as far as figuring out what percentages and temperatures affect what, as we've just talked about. Wet bulb, dry bulb, relative humidity, dew point. All of these factors combined all have a reading that is taken into consideration by the air conditioning engineers who design systems for a typical building, depending upon these graphatical measurements and percentages. That's how they design the system for commercial buildings or industrial buildings. So it's a big part. Not that you have to know that in particularly, but this is just how it's done. This is what the method is used, is the psychometric chart. Let's move on here. Let's go to talk about some compressors. There's a compressor right there. That's a large basic compressor. Air conditioning compressors and refrigeration compressors provide air conditioning, heat pumping, and refrigeration for large-scale facilities and equipment. They compress low pressure, low volume gas into high pressure, high temperature gas. Refrigeration and air conditioning compressors also remove vapor from the evaporator. The air conditioning compressors are large-scale mechanical devices and are designed specifically for air conditioning systems. There are three main categories of commercial air conditioning compressors, and they are the screw type, the scroll type, and the piston type. The screw type compressor compresses refrigerant valves, vapors through screw spindles. This is the screw type compressor. Passes refrigerant through screw type spindles which compress the gases. The scroll compressors are the most common type. They have a relatively low rate of leakage and they provide high efficiency. So they're the most commonly used. The piston compressors are reciprocating compressors, are specially designed for commercial and industrial use. All of these compress gases to high pressure and are designed for continuous use, continuous operation. So let's see if we have any more pictures. That's another compressor there in an industrial situation. Let's talk about dehumidifiers. Dehumidifiers is an air conditioning-like device that controls the humidity of a room or a building. It is often in a food retailing establishments. Large open chiller cabinets are highly effective at dehumidifying the internal air. Basically, a dehumidifier takes moisture out of the air. And you'll find different types. Here's a larger type dehumidifier. This is a portable dehumidifier, which can be brought into office type situations and dehumidify the air. There's also smaller ones. This might be a window type or a space type dehumidifier that you just put in a certain area to dehumidify an area. Let's talk about humidifiers. Here's some pictures of some commercial humidifiers. A humidifier is just like a dehumidifier, except that it puts moisture into the air. If you have a need for moisture in the air, depends on how much moisture you need or what volume of moisture you need, but you will be looking at one of these type of units. It's pretty basic, basically the same as a dehumidifier. It's an air conditioner looking device, and its purpose is to replace or add air or moisture to a room or building. So basically, dehumidifiers and humidifiers basically look and do the same job. One takes the air out, one puts the air back in, the moisture out and the moisture back in with the air. Here's another large type humidifier. You'll see this type up on a roof assembly. Let's see what else we have. We have chillers. Here's a diagram of an office with air handlers and a chiller. And you'll see chillers, commercial chillers are a device that removes heat from liquid using vapor compression technology. Commercial chillers reduce the temperature of liquids, often water, though other liquids can be used to be cooled by chillers, for industrial and commercial applications. Commercial chillers utilize four main components. They utilize a compressor, they utilize an evaporator, a condenser, and a metering device. Commercial chillers with a closed loop system, which means that the coolant remains in the chiller and recycled across many uses. A closed loop commercial chiller contains a separate tank that filters and cleans the coolant before returning to the main source area for reuse. So it'll have a tank on them if it's a closed loop system. Let's see if we've got another, we've got another picture of a commercial chiller here. This is on a rooftop, big, huge chiller on a large factory or a large industrial or commercial property. Condensing coil. A condensing coil is a condenser condenses the liquid gases by cooling it. When the condenser is running hot, refrigerant gas coming from the compressor enters the condenser coil at the top. And as it passes down through the condenser coil, it cools. Condensers, whether it employs water or air, should ideally eliminate the heat from the refrigerant to change the superheated vapor that is discharged from the compressor and convert this vapor into a saturated liquid, or subcooled is another term. The heat eliminated from the compressor is the same as the heat absorbed at lower temperatures, such as when the evaporator and the heat equivalent to the work output into the vapor of the compressor. So let's see what we got. We got a couple of pictures of another picture of a condensing coil, I believe. Yeah, we've got copper tubes going through here, and then these are the fins. You've seen a lot of these on regular compressors or condensers of commercial or residential, in particular residential air conditioner units. Same situation, only on a larger scale as far as the industrial and commercial application. Next, we're going to talk about cooling tower. I want to say, excuse me, I've got sort of a raspy voice. My throat's a little acting up here, so I apologize for that if you noticed that. Let's talk about cooling towers. Big commercial properties will have cooling towers, and what the cooling tower function is is a cooling tower functions like a to cool a circulating system of water, stream of water. The tower acts as a heat exchanger by driving ambient air through falling water, causing some of the warm water to evaporate. Evaporation gives off heat and provides cooling, and then circulates the cooler water, back through whatever equipment needs cooling, such as a chiller or a condenser, something of that nature. So that's basically what the water's doing. It's forcing air through a stream of water coming down through these cooling towers. Let's see if we've got another shot of one. Here's a diagram. We've got a cooling tower up at the top here. These are some ducts. Here's a diffuser. Here's a thermostat, thermical unit here. Here's our boiler in the basement. Here's our chiller that we've talked about. Basically, that's just a little diagram of how the chiller, the cooling tower and the chiller, where they're placed, and how this outside air intake coming down, and then we got an air handler down here that takes the air and moves it through the ductwork and whatever. So that's just basically a diagram with our cooling tower at the top up there. We talked about air handling units. Here's a couple of air handling units. This one happens to have some work being done on it. There's some tools and some parts here. Looks like a maintenance worker maybe doing some work on this unit here. An AHU, the air handling unit. This is a device used to condition and circulate air as part of the heating, ventilation, or air conditioning system. The air handler is usually a large metal box containing a blower, heating or cooling elements, depending, filter racks or chambers, sound attenuations or attenuators, and dampers. Air handlers usually connect to ductwork that distributes the conditioned air through the building and returns it to the air handling unit, or the AHU. Sometimes AHUs discharge supply and return air directly to and from a space served without any ductwork. So you may run into one of those types. Let's see if I get another picture here of an air handling unit. Here's a larger air handling unit, and each of these compartments open up has maybe a burner, possibly a motor. We've got filters that could be changed. Each of these compartments opens up and has something in there to look at or to work on. This one happens to be a large air handling unit, and it stands up on a roof with these pads. Here again, for the reason that it doesn't sit completely flat on the roof and build up with water to enter that, there's always some 4 inches of lift on these bigger units, just like on a transformer or switch gear that we talked about in our electrical videos. The next thing we're going to talk about is an expansion valve. This is an expansion valve right here. The expansion valve senses the pressure of the refrigerant coming into the evaporator, as well as the temperature of the refrigerant as it leaves the evaporator, and then meters the flow of the refrigerant into the evaporator to keep it almost perfectly within the engineered specifications. Here's another picture of an expansion valve in use, mounted. The evaporator coil, which we see here, in the evaporator, the liquid from the expansion valve is changed into vapor while it absorbs heat from the conditioned space. It transfers the heat energy from the passing air to the refrigerant moving inside it. As the liquid refrigerant absorbs the heat, it is boiled off or evaporated as it moves through the evaporator. The building air temperature drops as it passes through the coil, pushed by a blower fan or blower fans. Depends on how big the unit is. There could be more than one fan. Evaporators are usually made of copper tubing and closely spaced aluminum fins. And here again, we talked about this. These are the closely spaced tunes, or closely spaced fins, excuse me, and here's the tubes. There's the copper tubing. Basically like a condenser unit on a residential air conditioner unit. That is just about it. I believe that covers most of what we're going to talk about. I do want to say one other thing. I do want to talk a little bit about the SEER rating, and that's the rating that is used. The coefficient of performance, or the COP, measures performance, but this dimensionless measure has not been adopted, but rather the EEF ratio, which is the energy efficiency ratio, has been adopted, and that is what is used, is the EER. This is the energy efficiency ratio based on a 35 degrees Celsius outdoor temperature. More accurately described, the performance of the air conditioning equipment over a typical cooling season, a modified version of the EER is used, and it is the seasonal energy efficiency ratio, which is the SEER rating, which is what we deal with today. The SEER ratings are based on seasonal temperatures, advantages instead of a constant 35 degree outdoor temperature. It's seasonal temperatures. So the current minimum, industry minimum SEER rating is a 13 SEER. That's the minimum rating right now. So that brings us to a conclusion. Oh, sorry, there's one more picture of an evaporator coil here. You can see the fins in this larger evaporator coil. And I believe that will do it. Thank you for joining me. I'm Dan McCarthy. We'll see you next time.